Hello, Triscom here. Welcome back to TIS-100, where we are going to build, apparently, a signal edge detector. That is what we have to do now, so let's go ahead and create a program to do exactly that. All right, so read a value from in, we'll compare a value to the previous value, write a 1 if it's changed by 10 or more. If not true, we'll write a 0 instead. The first output is always 0. Cool, so communication failure, blah, 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 blah. Days and days, cycles and cycles, and just one after another. I'm sick and tired of people who don't respect me. Time to pack it up. All right, so that is what's going on now. We need to compare this thing to the previous value, and then write a 1 if it's changed by 10 or more. Okay. So, what do we have to do? So we gotta, let's see. We're gonna write a signal edge detector. So we're just trying to write out if these things change by a significant amount. Let's see if it's changed by 10 or more. Okay. So, first thing we need to do is we need to move up to the accumulator. Yeah. Hang on. Yeah, I'm going to just say this one's job is to move 10 to the right. All right, so we're going to move up to the accumulator. We're going to move, let's see, we need to get, so let's see. Well, we'll worry about writing a 0. Well, shoot. We'll worry about writing the 0 later. Okay, so we'll move up to the accumulator. Then we are going to subtract up. Yeah, let's, and then we are going to say, let's see, so we said subtract the right, and then see if it's greater than 0, right? If it's changed, if it's changed by 10 or more, shoot. So a negative value is still valid. Okay. Shoot. Let's see. All right. What we care about. Okay, so what we care, let's first just get the difference, right? So we're going to move up to the accumulator. Then we are going to subtract up. We'll ignore this move right thing for now. Let's go ahead and delete that. Subtract up. So we move the thing up to the accumulator. Then we're going to subtract the thing at the top. No, we can't do that. We need to save it twice. Okay, we need to move up to the accumulator. So this one can't do the processing because we still need that second value. We can't just subtract it because then we lose the value. So we're gonna do the actual logic over here. It can worry about it. So move up to the accumulator, move the accumulator to the right, and we'll move the accumulator to the right again. Yeah. And I guess this first one we'll have to just, I don't know. We'll have to discard, I guess. I don't know. So this is going to just double the things that double our input, right? So we're going to get 0, then we're going to get a 0. And, right, okay, that's fine. So first we'll put up to into the accumulator. Put left into the accumulator. And then we can say subtract left. Well, let's get rid of the first one for now. First, move left to null, to nil, to the nil register. So discard the first one because right now we've got the 0. We don't want to worry about it. So we move left and then we'll subtract left. And then we still got it left over for next time. So good. So subtract left. And let's see. Okay, subtract left, and that should get us the difference, right? So we should end up with the difference. And then we'll want to go, if it's less than 0, then we want to invert it. Yeah. Shoot. Okay. Let's move left nil. Actually, okay, so we get 0, then we go there. Which is 32. Yeah, so let's just get this. So this square's job is just going to be to output the difference between the two numbers. That's all. We're not going to do the actual signal detection. We're just going to output the difference. So if that is, okay, so first thing is it's moving left to nil. I'm going to say begin is actually going to be here. This is just like a flushing it out to begin. First, we're going to move the left to the accumulator, then we're going to subtract left. And then we're going to, we'll say jump if it is, well, let's see, negate. Yeah. And so assuming that it's negative, we negate, and then we'll say done is the label, and that is just move the accumulator down. So substitute the left and then negate it. But if it is not less than 0, then we don't need to negate it. So we'll say jump if less than, jump if greater than, let's see, shoot. Jump if greater than 0. Yeah, negating is fine. Jump to done. And there we go. And then we'll say just jump, jump to begin here, because we got to not move this left to nil thing again, I think. All right. Let's see how this does. I'm just going to move up to down so we can watch how this works. It's not done yet, but we should at least be now getting the differences in a positive value. So the first value that we get down, okay, it's substituting. Let's see. Now let's get negative 32. Turns it into 32 and takes down. All right, we sent down a 32. Right, that's not right. 32 minus 0. It doesn't matter which version we subtract, because we're negating it anyway. That's fine. Okay. So we can say if it is great. So we get the difference, and now we can just say if it's greater than 10, output is 0. If it's so now we get the difference, and it should be positivized. I hope. We'll see. Who knows if that works? It was kind of hard just stepping through that stuff. We'll say so we'll move up into the accumulator, and then we'll say subtract the right. And we'll say the right's only job is to move 10 to the left. So it's just giving us 10. Oh, actually, we can just do sub 10, can't we? Yep. Yes. And if it is greater than 10, then we're going to, let's see. If it is greater than 10, no, we subtract 10. And then if it's still positive, then we need to output, yes, we need to output 1. Otherwise, we need to output 0. So let's see if we can do this. If, let's see, well, we'll put begin here, and we'll say jump if greater than 0 to detect, because we detected it. I'll say detect is a label here that says move 1 to down, and then jump to begin. And here is the else case, which is move 0 to down and jump to begin. Okay, now we can delete this, maybe. Let's see if that works. Okay. So the first value that we get is a difference of 32, which is greater than 10, so we should push a 1 down. Good. No, not good. Because of this move, yeah, because we've got to start off by putting a 0 down. What happens if we just get rid of this line? Get rid of this. It's probably going to break, right? We get a 0. Good, a 0. And then a 1. Nope, then we get another 0. All right. Shoot. How are we going to... Wait, hang on. How does this happen? All right. We move up to the accumulator. Right, we get this value twice. We get a 0. We get a 0. Oh, right. No, that makes sense. That is correct. Right? So that's good. We move a 0 down. Now, for what... Okay, so the difference it's finding is less than 10. Wait, why is the difference less than... Right, it's negative 10. Right. And so that is not a detect, so that moves a 0 down. That's correct. Now, up here, we just got a 32. Oh, we subtracted a 32. Right. So this is wrong. Move the accumulator right, move the accumulator right. So first we need to do, problem is we passed in an extra 32. Okay, so we do need that jump. Move left to nil. Yeah. No, hang on. We can do this better, can't we? We can do this a little bit better. No, okay. We'll do this like this. We'll just put the extra 0 here. Move 0 down, and we'll say this is the begin. I'll say jump to begin. So its first job is just move 0 down, and then it never does that again. So first it moves a 0 down, and now we should get a 1. 32 is the difference. It is detected it's a 1. We get a 1. We get a 0. We get zeros. Well, let's run this. No! Dang it. All right. Oh, sweet. I can click and then pause. Okay, stop. Now what are we dealing with? We have found a negative 11. We have negated it, and we are moving that down. Wait a second. Why are we negating that? Jump if it's equal to... Oh, hang on. Jump if it's equal to 0. No, we don't want to jump if it's equal to 0. We subtract and jump if it is less than 0. Jills. No, that breaks right away. That breaks in all of the cases. Oh no, this is going terribly. All right, what are we going to do? We're going to move the... Let's see. Okay, so we subtract to the left, and we say, hey, is the difference... Let's see. To 0... Oh, wait, no, sorry. Jump if greater than 0 to done. Otherwise, negate it. There we go. That's what we want to do. Hopefully. We're always so close to... Nope. Dang it. How do we screw this up? What the heck is going on? All right, well, let's run this to the 9, I guess. Well, stop and run it to the... Run it over to that one. Nope. I believe there's actually a way to debug at a particular point. All right, so we've got a 9. We've just pushed down a negative 6. Why does the accumulator have negative 6? Oh, wait, no, it has negative 6 because it subtracted that. That's fine. We went from a 19 to a 9. Okay, so it's losing... No, that doesn't make sense. The accumulator is there. Moves a 10 down. Subtract 10. Oh, a 10 or greater, not a 10. A 10, yeah, because it's exactly 10. That's the problem. We were subtracting. Yeah, okay. Let's see if that handles it. There we go. Look at that. It is working. Wonderful. Okay, let's run this fast. Okay, good. The test passed. And we used more instruction counts and more nodes. Well, we only used 4 nodes, and apparently that was fewer than a lot of people ended up using. Let's go back to the segment list. That was more challenging than I thought it was going to be. It's hard to even understand exactly what it was that we were doing. Let's look at that again. So we move up. Yeah, so we just do this to save the thing, right? And then we have to do this initial thing to... I feel like there's a better way to do this, to avoid having to remove this nil and to add this move 0 down that we just never jump back to. But hey, it is what it is. Let's go back to our segment list and see what we can do about this interrupt handler. All right, interrupt handling. Read from in.1 through in.4. Write the value number when write the input number when the value goes from 0 to 1. 2 interrupts will never change in the same interrupt cycle. Okay, cool. This seems like it should be easy. Who knows? So let's look at the debug. Compute node diagnostic, microcore dump. My sister was over the holidays, I think to check on me, make sure I haven't gone off the deep end. I know I caused some worry. Her kids saw me working here and suggested I could surf the web for TIS-100 specs. So even kids are on about the internet, online, blah, 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 0x7. It's a racket. I don't care about the information superhighway, and I never will. Okay. So, oh, we need to just detect the edge, not detect if it is 1. We just need to detect if it goes from 0 to 1. So let's see here. So the first thing we need to do, let's see. Let's just get so here's the output. Let's get in 3 working. The interrupt for 3. Well, okay, let's get the interrupt for 4 working because that's the first one that it's going to expect. So we will say move up to the accumulator and then say subtract 1, and then if it is greater than, let's see, subtract 1. Let's see, if it is 0, then it'll be negative. If it's a 1, it'll be 0. No, so this is a state machine, right? So there are actually 2 loops. One of them is a 0 waiting to go to a 1. And one of them is a 1 waiting to go to a 0. So there are 2 different transitions. So a state machine is when you basically have, basically this is following 2 different steps. And so it's going to jump. So let's call this inactive as the first loop. And that's where it's going to start. So this is our label for inactive. That's going from 0 to 1. We'll put a comment here. 0 to 1. And we'll say active is another loop. Goes 1 to 0, possibly. Those loops will be implemented separately. And if it goes from, so if it's inactive, then basically all we have to do is, let's see, wait until we get a 0. Yeah, wait until a 0. And in inactive, we'll say wait until we get a 1. Now we have to devise the logic to that, but also if we get the 1, then if we do get the 1, then we're also going to do some jumping stuff. So active first going from 0 to 1, because these are going to both be pretty darn similar. Let's see, how can we detect if we go, so assuming that we were at a 1, let's say a 1, yeah, so we'll move 1 to the accumulator, and then we'll subtract up, and we'll say jump if we're equal to 0. Let's see. If we get a 0, jump if greater than 0 to inactive. Right? So that's all we have to do. We say, hey, we know that we're currently active. We got turned on. So we're going to say, we're going to put 1 in the accumulator. We're going to subtract the thing that is above us. And we're going to say, hey, if it is, let's see. Yeah, if it is a 0, we went to inactive. Then, so good. All right, so inactive now. We're going to say move. This one will be a little different. We'll say move the accumulator, or move up to the accumulator, and we'll say, let's see, subtract 1. So we can move a 1 there. We can move a 0 there. If we move a 1 there, then that's the exciting case. If we move a 0 there, then that's the boring case. So if it is a 0, let's see. All right, yeah, sorry, we forgot the other case here. Otherwise, we're going to jump to active. We subtract 1. If it's a 0, jump if it's equal to 0 to inactive. Because, sad day, it's still a 0. Otherwise, then we can move 4 down. And we would now jump to active, except that it's right there, so we don't have to worry about that. So let's see if that actually works. So it gets a 0. It says -1, so we're still inactive. Wait a second. No, it moves the 4 down right away. Whoops. We subtract, right, sorry, jump if less than 0. Joules. So if we're less than 0, so we subtracted 1, and if that means that we get a -1, then nope, sad, we're still inactive. So it goes, oh, we got a 0, so we're inactive. Let's get another one. Yep, we got a 0, so we're inactive. We got this. We didn't get a 0, so we must have gotten activated. So it's going to move a 4 down. Let's just shoot. All right. Just to step through this, move up, down for the moment. We'll do that. Okay, so move this down. Move that down. Yep. And now we get a 4. Hooray. And now it's in the active loop. So it is waiting until it becomes deactivated to output anything at all. There we go. And now one other thing that we're going to have to worry about is actually outputting these zeros. So one thing I'm going to cheat on with, I guess, a little bit is while we are, let's see, jump left, 0 to interactive. Well, actually, also we can shrink these. We can shrink these up. Excuse me. Oh, no, let's see. Okay, we'll call this dead. Well, actually, no, we'll call this off, and then we'll say on, right? Just to be simple. Jump to on, and jump to off. So we got to just determine when these things go off and on, and we'll turn this to off, and that should still work. It's still going to output the 4, and that's going to try and output another 4, right here. Yeah. So next time it turned on, it went to there. So that's pretty good. Jump of less than 0 to off. Let's see. Do I jump of less than 0? Right. So jump down to there. Yeah. The only problem is we're going to need to determine. Yeah, we need to output zeros. So really what we're going to need also is to freaking sum stuff. We're going to have to send stuff over, which is annoying. So we actually got to change, instead of jumping to on, we also, so let's see. Activate is going to be a label. And that is going to be move 4 down. Ah, man. All right, switch is going to be move 4 down. Because otherwise we need to move a 0 down. So we'll say jump if something. Well, we'll worry about that in a second. So we've got these 3 different. We've got 2 states, but then we've got the thing that happens on the transition, which we have to worry about. So we subtract 1, and then it's less than 0. So that means sad panda. So actually, we can just do jump if it's equal to 0 to switch. So we say, hey, we got a 1, so good. Otherwise, we'll move a 0 down, and then we can jump to off again and start that loop over. Yeah. Let's see if that works. So then we should get a 0 first. So we get a 0. Good. And then we get another 0. And it's now blocked up. So, okay, that's fine. We'll assume that that is valid. Well, actually, no. Let's move up to... I'm just going to start shuffling these things around so we can at least get a little bit of a sense of how far... Let's see, move this to the left and move right up. Just to track these. Okay, so we get a 0 and a 0 and a 4. And that's what we do expect. So 0, 0, and then, well, we get the 1. But that's fine. Okay, so we do get the right values. That means that we should just be able to copy paste this whole thing, except change the values. I'll change this from a 4 to a 3. Okay, so this will be register 1. This will be input 1. This will be input 2. This will be input 3. And now all we have to do is sum all of those values before we push them down. So we'll say move up to the right, and I'll say move up up to the accumulator and add the left, and then move the accumulator to the right. And then here I'll say move up to the accumulator and move, let's see, add the left and add the right, and then move up down, or move the accumulator down. And then here, we aren't going to move up to down, we're going to move up to the left. And then we'll move up down here. Yes. Let's run this. Get a 4. Oh, no. No. What happened? Okay, so what's going on? We've got 0s coming in. Well, we've got 0s. We're waiting for somebody. Oh, hang on. We're not getting all of these. Yeah, we are. We are getting all those values. Accumulator to the right. No, we are consuming these things incorrectly somehow. We're adding the left. We're adding the right. Move up to the accumulator. Move up to the left. How did we get it? Okay, so we got a 3. 3 should have okay, we did get a 3 there. We were expecting a 1 there. Now we are adding all these values together, but it shouldn't matter because we should be adding 0s for all of the rest of them. So what happened? Let's step through this. So there we go. We got 0s on all cylinders. So it moved up to 0. It's going to add. It's waiting for the stuff from the left. It's going to add the right. So it got a 0 and it moves that down. Cool. Now it gets a 0 from there. Actually, you know, we should, just to make this a little faster, we should add the value from the right, because otherwise we're waiting on the one from the left longer. Okay. There we go. We get the 4s. Okay, so we got the 4. Now we're getting 0s. I'm very confused as to why we're not getting the right values here. Why is the 4 just getting... Let's see. 4 is somehow reading way more inputs. Why is 4 reading more inputs? What the heck is 4 doing? It shouldn't be able to do anything. There's no reason for it to be doing... This is exactly the same code. So how is it ending up jumping ahead? That's the thing where I'm confused. Subtract 1. Oh, wait, no, I take that back because it is already on. So it's going over fewer steps. We got a 3 here and we did not expect 1. All right. Why did 3 say something? Or did we get 1 and 2? Yeah, hang on a second. We're not writing any zeros while we're turned on, are we? While we're in this, are we? I don't think we are. On's loop does not do any move 0 downs. Yeah. Let's see if we can fix this. I'm kind of shocked as to why 4 happens to work. Move 0 down. Yeah, so it's still also not doing a state change. Actually, this needs to happen before we even subtract up, isn't it? Maybe. Who knows? Move 0 down. Nope. Nope, we're still broken. But I think we got further, didn't we? No, we didn't. All right, we made a huge mess. All right, let's look at these 2 loops again. Let's check this stuff out. Let's look at this. All right. So we have these 3 things. So the first thing is, while we are off, what we should be doing is we should be checking to see if we change. If we do change, we should do something crazy. Otherwise, we should move 0 down. Okay. So this loop I think is fine. This loop is accurate, right? I'm going to assume this loop is accurate. I'm assuming also that these summers are fine because I can't imagine a way that they could be wrong, which is probably just failure of imagination on my part. Okay, so if we are equal to 0, then we move a 3 down. Good. Otherwise, we move a 0 down. Good. And then we start over. That's all that does. It seems correct to me. Now, the on is going to say, okay, if we are equal to 0, then move to down, move off. But either way, it needs to move 0 down. Yes. Yeah. Either way, it needs to move a 0 to down. Doesn't matter which way it goes because it's not going through this whole switch transition thing. It needs to push a 0 down, even if it goes from being on. If it stays on, or if it goes from being on to off, it still needs to push down a 0, no matter what. I feel like they've also set these sequences up to be a little bit tricksy. Let's go ahead and run this and see. And look at that. There we go. We get these numbers going just fine. And let's switch this to fast. And there we go. 237 cycle counts, which is apparently on the high end. And some people found much better ways. We're using more nodes and way more instructions, but it works. And we've not unlocked. All right, okay. So we've completed all of these steps. And the next stuff that we have for next time is going to have to wait for next time because, oh man, we've been going for a while. So I'm going to have to do some editing there. I hope that, oh man, that was rough. Couldn't figure out exactly what was going on there for a little bit, but thankfully, I think we've now got it working and we can maybe go back and try and improve that at a later point in time. But we will have to review that next week, and I will hope to see you then. Cheers.